Hello everyone. Today I will present to you our mini group project. It is plant preservation and observation system, the system that will take care of your plant while you are away. And how does our project work? This is a mini project that made for the plant pot that it will watering itself when the plant is needed. It will reduce the workload of the people who use plant pots, and it reduces the responsibility to maintain the plant healthiness over time. And how does our program can be applied into a real world? If we apply our program and our components, the plant can be watering rightly in the time which mode it is suitable for that plant type. The user can adjust it by using the potential meter. Why would not overwhelmingly watering the plant if it not needed, such as when people has watering it by themselves, or maybe the rain has fall, it will not water so it would end as a routine watering work which save the time and if able, it would be able to work in a higher scale such as farming. But however it is need to be adjust more for each plant and bigger scale. And let's see our pin utilization and components. Our pin utilization involves several pins and several groups. First, it is serial clock line SCL. Second, serial data line SDA. Third, it involves 11 digital pins. And fourth, it involves one analog pin. This is for R3 only, it will involve the max later. Because of our project need analog pin than we can expect it, so we need max to expand the analog pins. So we have utilized 7 analog pins to be in use and expanded by max. Let's see what it do. This is how user can input. User can use the potentiometer to adjust the number of the soil humidity threshold the plant need to use before watering, because each plant doesn't use the same amount of water they need. So the user need to adjust that by use the potentiometer themselves. However, if you doesn't want to use this method, we still have the default number for watering. This is our sensor bank. This is a collective of sensors which collect the data of humidity, water level, and temperature, and rain too. The sensor will collect the data from both the air and soil. Our sensor will check for the humidity threshold. If it doesn't rain, water, or anything related with water, it will, if it's under the threshold of the humidity, it will autonomously watering itself to the plant. And next is output. Output work differently in different job. First, we have our relay water pump. The relay water pump will pump the water to the plant when the humidity is under the threshold. Second, we have the OLED. OLED will display the value of the each sensors. And the third, we have the buzzer. Buzzer will buzz when we are starting the watering system. And second, it will buzz when there are errors in the system to alert the users.
So here is the adaptation of the layout of the circuit. So we separate into two main zone. The wet zone of is the pump itself, and the dry zone. The dry zone will be the circuit itself. So we will have one voltage jacks to accept the power of 12 volt into the system. The system will separate into two lines. The main two lines. One will be on to step down to power the R3, and then one will go into the pump itself with the relay to control which one to turn on and turn off. And then we will have this breakout board that we almost have every module on it. And then we have the R3 and the step down. So, and this will be the back IO. The back IO will have 5 of 2 pin and then 3 pin of 2. So the 2 pin will have 4 of them will be the soil sensor, and the last one will be the rain sensor, and this one will be the water sensor for the water tank, and this one will be for the DHT22. For the DHT22 we have one internal and one external to the average out of the any alert that sensor might pick up. And then because like the water level we need to have, because the pump cannot over pump itself. It will burn out if it get too hot because it use the water that is got in to cool down itself and lubricate the diaphragm itself. And then we have the this one we cut it out because the chip burned itself when we assemble it and the crystal is broke. I'm not sure why, but this one will be cut out. And then this will be our buzzer. We didn't peel off the sticker because the buzzer is already loud enough even with the sticker is on. So this is 5 comparator, including this, because 5 of this we use for the 5 of the port itself. And then we have max. The max need to have it because the max have the option to have 16 channel of analog pin. We cannot use the analog pin on the Arduino itself because the last 2 pin is SCL and SDA. So because we also have the OLED itself to output, we cannot use the A4 and A5. So we use the max to get the SCL and SDA working. So after all of that, because this will be too exposed for even like deploy in the farm, we come up with a case solution. So this is our cover. The cover will also already have the OLED and the potentiometer on it, but we come up with a genius way we use magnetic embedded in the plate itself, so we can do something like this. So it will snap in place on both sides, and then we only cut out the pass through for the tube itself under there, and then we cut off for the channel relay, and then we will snap in place, and then everything will be stand up on the stand, and we will have the tube going down, and then we will have the stand to rise it for the tube to go down. Thank you. So here's the code part. So first we start with the calculation of the pin itself. So first section will be the selector pin of the max, and then we will have the buzzer pin, the DHT22 pin, and then the relay pin. And then the channel mapping of the relay, the max pin for the comparator, it will be 0, 1, 2, 3, 4. And then for the water level and the potentiometer on the front will be on 14 and 15 of the max. And then we start with the constant of the code. So we can set the rain threshold, water threshold, humidity skip, water duration, unsigned long page interview for the OLED itself when we need to change the page. And then the last port value, so we just make it negative. So it will make it read every time. And then we will have the display override. Will be unsigned long of port move last time and then port change, so it will be sensitive enough to override the OLED when we display anything. So next will be the voice setup. So we will start off this program of the calculation of the pin mode of several pin. After that, it will initiate the ITC of the real-time clocks and the display OLED itself. But due to the hardware itself, is the ITC is broken, so we will cut the ITC off. This part involves defining and declaring the following. First will be the DHT sensor or digital humidity and temperature sensor for both DHT22. Second will be the port itself, the potentiometer to adjust the moisture threshold, and then we also put in the map here. Third will be the soil sensor when reading from the max. Fourth will be the rain sensor, also reading from the max. And then in the fifth, we will also reading the water channel sensor to pull the data if we need to buzzing or not. For our sanity and the code will never be perfect. We add a serial pin for debugging when we connect that to the computer itself. So when we open the serial monitoring, we can see what is it reading and then what is not reading itself. So this section will be the OLED display 3 2 1. So this section will be the only display control. Like for example, if the port value is not the same as our value, we can start to override the display, and then we will have the display of every page to switch case by itself. So we will starting from showing boot when we start the PCB, and then we will be on the case 0, so show temp, and then show soil page, and then show rain page, and then show relay status. So here is the only page, the first page. So it will show everything threshold. So this will be the only page 2. It will show the temps. So we start from clear, set the site text, and then we set the cursor, and then we read the temperature sensor from the DHT22 from both of them and display on the display. So now on the third page, so we use to clear first set the text size and then set the cursor to 00 so to start writing, and then because we have four of the soil sensor, so we can use for a loop to display all of them. So this will be the first page. So it will show if the sensor itself detected if it rain or not. For now, the fifth page, it will show all the relay status itself, if it turning on or off, or on what state itself. So watering logic itself, it will use the if the water tank is not empty and the rain is not rain yet, the humidity on the first sensor is not over the threshold, so we can assume that the plant need a watering. So we start with the for loop because we have four sensor and also we have four pumps, so we need to have one to one ratio. So we can start with the print itself out to debug, and then we have the digital light pin for the start to have the buzzing when the water is start watering, and then when the calculation itself it reach to the threshold, we can stop watering. So for the alert system, first we have the alert on when the system is start watering, and then the second will be on the if the water is low, it will beep two times, and then it will wait for the loop to complete, and then it will beep again. Same is the temp sensor, if it gone or not, it will be beep three times, and continue the loops. Now next, the real world. So this is the OLED part. So here is the OLED page going on, and then if we move the potential a little bit, it will read the new threshold almost instantly. See, from I set it from 0 from the start, and then now it's 36. Now we move to overview of the system. So right now I'm simulating, and we already set the moisture of the dirt to be 0, and this is will be simulated for the soil, but I will put the water in so the pump can pump it up. So right now the pump is all off, and then the temperature is 23, but the humidity is 24. But the port 1 and port 2, as we can say, is 57. But I packed it all, but I didn't pack the last two, so it's reading correctly, and the rain is right here. It's dry, so it read no rain, so it's correct. And then the water sensor, I fooled it right now by using a wet type, so it have a level of like 900 of water instead of like the maximum is 1024 right now, and we can set it to the max. And then if everything goes correctly, the beaver will not do anything right now. First pump is going on, the second pump is going, it correct the third pump is going, the first pump is going. Okay, so this is right, and the threshold is reading 100. Yep, and then it stop.
And that is all for our presentation. Thank you for listening and see you later.